TJ, come here.
Yes, boss.
Oh my god, TJ, did you know that our company revenue is dropping and that we're making a loss?
Not thanks.
We have to find a way to attract more customers by coming up with a more attractive insurance plan.
Medical?
Okay, TJ, I want your team to do a research on the market and give me an insurance price as soon as possible. But this price has to fit with the changes of medical costs in the future. Okay? Now go, quick! We are running out of time. You don't have to lose your jobs, go! As you can see earlier, I have informed my team that my insurance company is facing a loss in revenue, and I have assigned my team members to develop a new and attractive insurance plan to increase our sales. However, the plan has to adapt to the changing medical costs in the future. I believe that my team will be able to come up with a credible model, taking into account certain variables so that they will be able to successfully predict the future of medical costs so that we can come up with an appropriate insurance plan.
In our gathering of data, we have taken a sample data set on medical costs to draw conclusions about the insurance charges of the general population. So based on this sample, we have established the IID principle. The sample points are statistically independent. One point does not tell us information about another point, as well as identical distribution. Each sample point should follow the distribution of the population. We also fulfill the condition of CLT, since our sample size is clearly large enough with 1,338 data points. The sampling distribution becomes almost normal. So we import the CSV file onto RStudio and convert the categorical variables such as smoker and sex into numerical variables for our calculative analysis later. Then we also checked the skewness of the data apart from the categorical ones and found that the skewness of charges, the dependent variable, is more than +1 and hence right skew. Therefore, we use log transformation.
In order to determine the relationship between the dependent variable, which is log charges, and the independent variables, which are the age, sex, BMI, number of children, and whether or not they are a smoker, we have actually made use of the correlation test. With the test, we can see that in terms of the coefficient values as shown here, is that the age and smoker have high coefficient values, making them moderately correlated with log charges. That said, correlation alone is insufficient to properly deduce medical costs. Hence, we have made use of a regression model. As shown here on this regression model, the p-values, we can see that these variables are statistically significant and that based on the R-squared value, 76.3% of variability is explained in the regression model, making it highly reliable. And right here at the bottom is a regression model that can be used to deduce medical costs.
So according to the prediction from the researchers, there will be some changes in some of our independent variables. First of all, the BMI. Currently, the BMI mean is around 30 and the standard deviation is around 6. However, due to changing in eating habit and consuming GMO food, the BMI will have a tendency to increase in the future. It is forecast that the future BMI will follow a normal distribution with a mean of 35 and a standard deviation of 7. The same trend happens for the probability of people that smoke, which leads to an increase from 0.2 to 0.25 in the future. The trend of the independent variable has affected the dependent variable. To calculate this, I first set a seed at 100 to guarantee the same random values are produced each time you run a code. Then I apply the two new distributions to the regression analysis and run a for loop to create a new medical cost samples in the future. Finally, when comparing the two means, we can see that the mean of the medical costs in the future will increase compared to now. Therefore, we should charge the insurance price higher at around $1,594.
We used the t-based interval to figure out the confidence interval because we had to find out the standard deviation from the newly found future charges data. Based on the mean from the simulation analysis, we are 95% confident that the future charges will be between 14,430 and 16,157. We will price our insurance medical costs based on this range. In conclusion, We have managed to successfully predict the mean medical cost in the future to be 15,294 by evaluation through linear regression model and conducting tests on the variables. And finally, we came up with a plausible range for the insurance medical costs.
TJ, come here.